So then let's start. I think others will join later on. Okay, so this is the welcome to the week 10 of the joy of computing using Python course. So yeah, just 3 more weeks, like 2 weeks after this. So yeah, if you so what we'll be doing in this session is just we'll be solving some problems, some MCQs and some coding based questions. Yeah, so at any point if you have any doubts when I'm explaining, if you have any doubts or comments, you can use the chat. You can type it down in the chat, or when I finish, when I ask if someone has any doubt, you can also unmute yourself and just tell me if you have some questions or something. Okay, so let's start with some easy problems, and we'll go towards some more interesting problems later on. Okay. So first question is very simple. So what will type 9.0 return? So what will this, if you write in Python type 9.0, what will it return? Any answers? Very simple question. Can you speak up? Or can you write in the chat? Okay, float. Yes, you are correct. So let's look at some what actually happens. Let's look at some like what is the use of type. So type, as you expect, if you write 9.0, yes, it will give us float, and similarly if you write 9, it will give you int. So this type is very helpful when you want to understand, for example, you are taking the parameter of a function and you want to be certain that this parameter type is this. So you can put a check if, say, if type of variable equals to say string, something like this, or say int. So let's see. So that's why type is helpful. So if you give a string, something in a string, you get an str. It doesn't matter if it's like no characters or a single character. If you give a list 1, 1, 2, 3, you will get a list type. Doesn't matter if it's a list of integers or strings, you will always get a list. And yeah, by the way, I hope you know what lists can have. Unlike other languages, like other programming languages like C, C++, here in Python your lists can have actually any kind of like elements. Like this is a list. So your list does not need to have the same data type. It can have some strings, it can have some numbers, it can have another list, it can have a dictionary. You can basically put anything inside a list, inside the same list, I mean. So okay, so type, that's how type works. And then you can also see type of if you do a dictionary. So this is an empty dictionary, just braces start close will give us dict. So this is very helpful when you are trying to understand what is the type of like variable you have. And yeah, it will be more helpful. So in real world it is used mostly when suppose you are writing a function that will do separate things for separate data types. For example, suppose if you were trying to write a function where it works with a string. Suppose you are modifying a string, doing something with a string, but it also you want your function to also work with a list of strings. So you can put a check. So if it's typed string, then you just do the operations on it, and then if it's not a string, if it's a list, then you can say run the thing on each of the items in the list, something like that. Okay, so that was a quick question. Let's go to the next one. So question number 2 is, so we have these 2 lines. So what will be the output of the following code again? So we have a list A, which is defined like this, blank HEL blank LO. So what do you think will be the output of this? This I think it will be better if you write in the chat, because it is difficult to say. So obviously you can run it in Python and check what it shows, but I will I would like you to try to do it yourself. Someone try to solve it. Okay. Yes. Okay. So let's go ahead. So what the problem? The only thing that you need to know about this is what is this join function. What does this join function do? That is the main part of this question. So this what this join does is it obviously this join is used with a string, so it's an attribute, it's a function inside a string. You can use it with any string. So let's go to the code. So you can, for example, use a dot join. Sorry, join. So any string dot join you can do. Apparently it does not work. Okay, let's do it like this. Join. Yeah, I don't know why it didn't work back then, but yeah. So okay, so if you see that doc string, like what the help of this function, so join is basically concatenates any number of strings. So it works with a string and it takes a iterable as input. By iterable, for now you can just think an iterable is just like a list, anything that you can count over, right? So not a set, but you can use a dictionary, you can use a list. So what it does is it joins all of the items in this iterable, like A, B, P, Q, R, S, and it joins it by this string that you are calling it with. So here the example is quite similar to what we are trying to do actually. So for example, if you are calling with dot and then A, B, P, Q, R, S, so you can see that it will join those strings in the list with dots. So AB dot PQ dot RS. So this is very helpful when you are trying to say print a list of basically a list with spaces. Also note that this dot, this is not coming in the beginning or at the end. It will only come in between the items in the list, not in the beginning or the end. Okay, so coming back to the question, so if you have something like blank H E L blank L O, so basically we will get blank dot, so basically dot H dot E dot L dot, then like here there will be two dots in between because here it's like blank, and then L dot O, and then nothing after O. So yeah, obviously, so let's see, it will look something like let's just write it and we'll find out how does it look like. Let's keep it to this. Just a second. Okay, let's keep it like this. So we have the L or A, whatever, as blank H E L blank L O, right. So this is our A. So what will happen is like we'll have a dot H dot E dot L dot dot L dot O, but let's try it. Dot join. Yes, so for these problems, just yeah, so you can see, so it starts with a dot and then there are two dots in between, no dots after O. So these kind of problems you should try to first solve them yourselves, not like don't write in Python. First try to solve it yourself, then to check the answer you actually can write and see. So any doubts about this question? Why here are two dots, why there is a dot at the beginning, not at the end? Any doubts, anyone? You can write, if you have any doubts you can write in the chat or you can unmute yourself and ask me. Okay, then let's go on to the next question. I hope no one else. Okay, so question 3, something that we have done before, but I'll do it again in a better way. So suppose you are given a string S. So how can we replace all the vowels in that string with say a dash underscore. So this is like a code. So I will not. You can try to think about the solution, but I'll solve parallelly. So you can try to think how to do this. So suppose you have a string called, say, I don't know, joy of computing using Python, something like this, right? So what we want to do is in the question we want to replace all the vowels with a underscore sign, right? So like J underscore Y underscore F and so on and so forth. So how do we do it? So one thing is, do we have string dot vowels? I don't think so. Let's see. String dot vowels we have? I don't think so. Nope. Okay, it's okay. Let's define. So we can do it in multiple ways. So one way, and the simple straightforward way, would be to use string dot replace, s dot replace, where you give some input, like what do you want to replace it, what do you want to replace it by. Say a, we want to replace a with a dash. And if you print it, let's print it and see what do we get. So okay, there are no a's here, so let's try it O actually. So you can see all of the O's have been replaced, right? But the sad thing is you cannot just do something like A, E, I, O, U. If you do something like this, then you can see that nothing has been removed, because it is searching for this phrase A, E, I, O, U, but A, E, I, O, U is not present in the string itself. So it is not finding anything, so it's not doing anything. So what we need to do here is actually we just need to call it 5 times with 5 vowels. 4, 5. A, E, I, O, U, something like this, and that will do our trick. Oh, sorry, I have to print it. Print S. So you can see that all of the vowels have been replaced. So slightly better way of doing it would be something like this: CH for CH in A, E, I, O, U. Replace. So this is slightly better. So for character in A, E, I, O, U, you do this replacement. So this will give us the same results, slightly shorter. And then there is also this. So this is something that I am not going to go too deep into, but I will just give you a small glimpse. So there is this library called RE, which stands for actually regular expressions, or regex for short. So what it can do is, so it can do a lot of things using regular expressions, but for now I just want to show you a basic example of how you can use regular expressions to actually replace strings. So similar way we will do re dot. So here we did s dot replace. Here we will just call this library re dot sub, like substitute instead of replace. And so so first we have to give what we want to replace it, what we want to replace it with, and then what string, like s. So we want to replace it by dashes. I think that's clear. And then yeah, and what we want to replace is any type of vowels. So right, so this is a regular expression A, E, I, O, U. So inside brackets. So I am just telling that if there are any among these inside brackets, whatever I write. So if there are any of these characters, then you replace it by underscore. And you can see we have gotten the same result, but this is like a smaller line, right? So I am not going to go too deep into what this means and like what is this regular expression. But yeah, if you are interested, then you can definitely Google, and you can do things like star. So if you want some pattern, like there should be a vowel and then there should be not a vowel, like something like this, carat, A-E-I-O-U. So this will only match when there is a vowel and then there is a something that is not a vowel, and then it will replace that item with dashes. So you can see just now replace different things. Like for example, Python, O-N, it has replaced, right? So yeah, regular expressions are very powerful, but I'm not going to go deep into it. You can take a look. You can have like star plus things like that. But yeah, okay. Let's go to the next question. If you have any doubts about this question, you can ask. Any doubts? Okay, no doubts. Okay, let's go to the next question then. Okay, question 4. So again, straightforward, simple question. I think this one you should be able to do. You should be able to write in the chat. So just you are printing a slice of this string. You are slicing between 3 and 12. So what do you think the answer will be? Can someone write in the chat? What do you think the answer will be? I'll wait for a couple of minutes. Let me see. Let me also count and see. Any other answers? Okay. Yeah, so there are a couple of answers in the chat. So I think, yes, so Nipun, you are exactly correct, and Hans Raj, I think, yeah, you are on the right path. So yeah, it is like the same thing, but yeah, it is important to understand that the third, see, you are trying to slice between say element at position 3 and you want to go till before item at position 12, right? So you want to go till item at position 11. So let's start counting. So T is 0 position, H is position 1, position 2 and position 3. So 3 will actually be the space. So when we slice this, the first like slicing will start from this blank space. So there will be a blank space in the between. So then it will keep on going, and then if you keep counting, you will see that this C is actually the 11th item, and O is the 12th item, but we will not be taking because the last item we go till 1 before. So let's quickly test it out and see that our answer is correct. So joy of computing, yeah, so let's just try with this. It's the same thing. The joy of computing. Okay. So if you want to slice between say 3 and 12, then what we get is the joy of C, and note that there is a space before J, right? So follow up questions. So I hope you know slicing. So if you do something like this, do you know what will happen? If we just write colon 2, what will this do? Any idea? I hope you can see. So we earlier had just 3, 12, and now we are adding another 2. What will this do? Any idea? Anyone? Any guesses in the chat? So let's not waste too much time, but yeah. So what this does is this third parameter that you write after, like in the third parameter after the second colon. So this is like the step, like do you want to go one by one, or do you want to go one after another or two after another? So what this 2 means is that you are taking one item, you are leaving out one item, you are taking another item. So you are taking every second item, right? Like starting from the first, obviously. So if you print, you will basically get, so you are removing every every character in the even place. So if you run it, so you can see that the space is there, J has been removed, O is there, Y has been removed, space is there, O has been removed, F is there, space has been removed, C is there. So it is just printing all of the items in the even position, right? And you can also use say -1, something like this, but if you do this, you will not, I think you will get an empty string. Let's see. Yeah, empty string. So if you want to do a reverse, if you want to reverse a string, then you can do something like this. Yeah, so you have to do start from yeah, is it okay? No, so you have to start from actually 11 and go up to 2. Now it will be the same. So this is just the opposite of what you did before, what we printed before. This is the opposite you want to do. If you give a -1, or you can use a reverse ABC, something like this. I think that will also help. Yeah. Does it work? Okay. I have to do a list. Sadly. Okay. Okay, so I think this is the best way to reverse a string. Okay, I don't think there are any doubts, but okay. So let's then move on to the next question, question 5. Okay, so now we are moving to slightly more challenging questions. So let's start with this. So here is a piece of code. So you have to figure out what are we trying to do. What does this code do? Okay, or what does it print, and what are we trying to do? Just take 2-3 minutes to get the answer, and you write down in the chat. So we have a string S, शहर में, and we have the vowels in A. Then yeah, we are just iterating over the string S, and we are doing some calculations here. If this is true, then print that number, that index, and if that index is a vowel basically, then you are replacing it with yeah. So what are we trying to do here basically? Any guesses, or what is the answer, what we print? Yes, so we have some answers. Anyone else? Okay, So yeah, so Hansraj says it will replace every even position vowel with star. It's slightly more complicated than that. So what is happening here is basically, so yeah, if we just tested something like I mod 2 equals to 0 and then the rest of it, then actually it would be something like replacing every even position vowel. So yeah, what we are doing here is, so yeah, basically we are taking this. So suppose if we forget this print, okay, and if we think that we are first checking for vowels, we can just switch that to the two if statements. We can think that this if statement is outside, this is inside. So for each vowel, okay, so for if the character in the string is a vowel, like E is there, I is there. So for the vowels, what we are checking is s dot index si, right? So si is the vowel, and we are doing s dot index. So what s dot index does is it returns you the first occurring position of that character in the string. So if the first occurring position of that character is not in an even position, then it will not do anything. But if it is present in an even position, then it will replace. So that will be, this will be more well understood with some examples. So I'll just quickly write this code and then we'll see what's going on. So I'll just copy this code quickly. Let me write it down first. शहर में equals to okay. Yeah, by the way, you don't need brackets after if. Index si mod 2 equals to 0, string I, then if si in a, s equals to s dot equals to s, si. It's okay. Print s. So yes, so what this code is doing is basically you are replacing the vowels, but only if the first occurring character is like the first occurring vowel of that particular character is present in an even position, not just all of the even position vowels. Okay. So if you print something like that, so we are getting numbers. For now, let's forget the numbers. So for now you are seeing that yeah, all the vowels have been removed. But what if we just shift it? We just shifted it. We removed one character and now we run it. Now you can see that the E has not been removed, right? What if we do something like this? So now all of these secondary E's, they are present in even, the same positions. We have just offset this first occurring E, right? Now if we run, you can still see that the E has not been removed, right? So it actually depends on, so this was our original string. So if we just, you can see if we just change the position of the E, then it will not remove it anymore. Okay. So what this code does is basically, so it is removing vowels, but only if the first occurring, if that particular vowel is first occurring in a even position. So this is how you can actually, and yeah, obviously if you print I, then you can actually get some idea of which positions. So this is not very helpful, is it? Somewhat, but ठीक है. Okay. So if we do Shahar mein, yeah, yeah, so it goes like that. What do we do? Shahid. Yeah. So in this case, you can see that a lot less has been printed because these e's have not been counted anymore, right? Okay. So any doubts about this particular code, or we can go to the next question. Okay, let's start with the next question. So again, a very simple, just straightforward question, straightforward answer. So what is the shape of this numpy array, right? So you have this array. I hope numpy arrays were taught in the regular lectures in week 10. So what is the shape of this? So you are defining something like this. So what is the shape of this? Let's copy it and keep it here. Say import numpy arr equals to print air dot shape. So what will this print? What do you think? Any answers? Okay, so this is a straightforward question, nothing to, okay, someone says 2 cross 3 and that is correct. So, so in these cases you have to actually understand how many rows are there and how many columns are there. But yeah, so if you are thinking from a 2-dimension perspective, then yeah, rows and columns. So here we can see that there are 2 lists. So these are like 2 rows, and then we have in each row we have 3 numbers, so that is like 3 columns. So we will have the shape as 2, 3, right? So we can have something more also. We can have more deeper nested, like 3-dimensional matrices also. Something like say this. To fill some numbers. Let's fill some numbers, something like say 1, 2. 1, 2, 3, 4, 5, 6. Okay, so this one, now you can try this one. So I am showing you. What do you think will be the shape of this? 7, 8, and then 9, 0, and then 1, 1, 1, 0, and something like this. So what do you think will be the shape of this new array? Where does it show that? Closing parentheses. So what do you think is the shape of this? This is not a matrix anymore. This is like a, yeah, it is a matrix, but like a 3-dimensional matrix, not a 2-dimensional matrix. So what do you think will be the shape for this? Yes, so Nipun is correct. Exactly. So here also you have to understand the different dimensions. So first you have to understand the outermost lists. There are 2 outermost lists, right? So the initial shape would be, initial dimension would be of size 2. Then the secondary, there are like these, there are 3 sub lists in each list that you have to understand. So 2 cross 3, and then finally inside all of the inner list there are 2 items. So it should be this. If you run it, yeah, obviously there is a syntax error, but if you run it, you can see that it's 2, 3, 2, right? So this is like a 3-dimensional matrix, and yeah, here we don't refer to them as like rows and columns anymore. We refer to them as dimension 0, dimension 1, dimension 2, right. So if we say what is the size of dimension 1 here, then we will say that the size of dimension 1 is 3. Okay. And yes, obviously for NumPy you can use, I think that's the next question. Okay, so this was a straightforward trivia question. So next, now we'll put it to some use. So now we want to, so this dimension that I talked, this axis is actually the same thing. It is actually specifying which dimension we are working with. So in NumPy it says axis. If you are using something like say PyTorch, or in future if you are doing something machine learning, then then it will be called dimension. But yeah, here it's called axis, so it's the same thing, which axis, which dimension. So what do you think will be the output of this code? So let's copy it again quickly. NumPy as np, np.array. We have something like 1, 2, and then 3, 4. Right. And then we print something. We print np.sum, or you can just do b.sum. It will be the same thing. B axis just 1. So what do you think will be the answer? So what this means is basically we are finding the sum, right? So let's just first run it without this axis thing, right? So other than that, I think it's pretty straightforward to understand what this will do. Like it will basically do the sum of all the elements, right? All the elements in B. So if we just look at B once, you can see that B is like this 2-dimensional matrix 1, 2, 3, 4, and then if we sum up all of the numbers, we get 10. And that's what we are getting if we just do np.sum. So it is basically, you can think of it like it is flattening the matrix. It is just taking all of the numbers, which operation is called flattening. So it's like taking all of the numbers, putting them side by side, and then doing the sum, right? So but then again we had this was the original question. We have this axis argument. So what does this do? So this is, you are actually specifying that no, I don't want to sum over all of the elements in this list. I just want to I want to sum over this axis, right? So like I said, so there are 2 dimensions or 2 axes, you can say. So zeroth dimension here would be the rows. So like b dot shape, if you do, so it's a 2 let's do 2 plus 3, so it's easier to understand. Something like this, for example, say. So yeah, you already got the answer, but yeah. So what is going on here is b dot shape. Let's look at b dot shape. So b is now this. So there are 2 rows and 3 columns, and so what we are trying to do is we have to find out what is this axis 1, right? So the first dimension is the rows. So if you go first row, second row, right, or 0th row and first row, let's just call it first row and second row. So this is like dimension 0, and then we have 3 columns, right? So first column, second column, third column, right? So this is axis number 1, right? So when we are telling NumPy to add along the axis 1, what we are doing is basically we are adding the elements based on like the column wise. So we are adding the items in column 1, we are adding the items in column 2 and column 3. So which means like we are adding 1, 2 and 3, right? So our answer will be based on one item from each row. So this part is a bit confusing, so be careful about that. You might think that if I want to keep the rows, then I want to like if I want to like sum up row wise, then I have to give axis as 0, but actually it's the opposite, because you are summing along the other axis and you are keeping the values in the row axis, right? So if you want the rows, like you want the sum of these rows, you want the sum of 1, 2, 3, and you want the sum of 3, 4, 5, then you have to give axis as 1, because it will then add along the other axis, add along the column axis, you can see, and you can see the answer like 6 and 12. So 1 plus 2 plus 3 is 6, and 12 is 3 plus 4 plus 5, right? Similarly, if you give axis as 0, then you will get like the results you will get column wise, but the summation will be row wise. So you will, so 1 and 3 will be added, 2 and 4 will be added, 3 and 5 will be added. Okay, you can see that there are 3 answers now, 4, 6, 8, right? So when is this useful? So this is actually for 2D matrices it is useful, but let's go back to the previous array that we had. So we had this previous array, right? So let's just do it like this. NP. Okay. So in this case, you can actually specify which dimension you want to add in, and it will make more sense. Okay, B is not there, it's here. So now the matrix is like 3-dimensional matrix. You can see it's a bit difficult to understand, but like the first dimension has like this is one 2D matrix, and this is one 2D matrix. This is the 0th dimension, x is 0, and then there are like in each matrix there are like 3 rows, you can say, and then 2 columns, right? So the shape is 2, 3, 2, right? So if you want to sum along, so let's start with axis 2. Okay, let's just remove the axis for now. So if you just do sum, then you will get the sum as like sum of all the numbers, which is 78. Okay, now if we go back to say axis equals to 2, so we want to add along the last axis, right? So which is the individual numbers in this, you can say, columns, right? So what do you think will be the shape of the answer? So the quick way to understand what will be the shape of the answer is to just think that we are basically removing this last dimension, right? So we are removing this dimension, and we will get an answer which is 2 cross 3. So if we just run it, we can see that our answer is, so a space, yeah. Our answer is, you can see it is 2 cross 3, right? That's what we expect. So we are adding along these dimensions. So we are adding 1, 2, which is 3. We are adding 3, 4, which is 7. We are adding 5, 6, which is 11, and then so on. If you do axis 1, then again similarly, like I said, so the answer will be 2 cross 2. So you are just removing the middle dimension as if. So you can see the answer is 2 cross 2. So basically what you did here is adding 1, 3, 5, which is 9, and adding 2, 4, 6, which is 12, and then similar. And also you can add along axis 0. So similarly now our summation will be of shape 3 cross 2. So we are removing the first like axis 0, dimension 0. So our resultant will be 3 cross 2, right? So we can see that there is a 3 cross 2 answer. And yeah, so we are basically adding along the 0th axis. So we are adding basically, so this is a bit difficult to understand, but basically we are adding 1 with 7, we are adding 2 with 8, we are adding 3 with 9, okay, and so on and so forth. So yeah, this is where it gets useful when you are trying to sum different dimensions, when you are trying to perform linear algebra and stuff. And yeah, when so all of you know about machine learning and stuff, like at least heard of machine learning. So machine learning is basically nothing fancy. It is just lot of linear algebra, like lot of matrix calculations. Okay, so this is really helpful when you are trying to do that kind of advanced machine learning things. But yeah, I think let's not get ahead of ourselves. So let's solve. I think we have 10 minutes. Let's solve another question. I think we have okay, yeah. Okay, so another not too difficult question, but yeah, quite important. So how do we take a transpose of a matrix? So let's say we have a 2-dimensional matrix itself. Okay, so how do we take the transpose of this? So suppose we have our matrix in list, like normal Python list format, and then also in say NumPy array format. And how do we take the transpose? So let's, since time is short, let's just move on quickly. So suppose let's just take this array. Why not? Okay, now this is not this much. Let's say this is our ARR equals to something like this. So ARR is this. This is our matrix. Matrix is this. So we want to find the transpose. So this is, you can understand, this is like a 3 cross 2 matrix, right? So we want to get the transpose. Yeah. So how do we do that? We want to basically swap the rows and columns. So basically we want 1, 3 is 5, and then we want something like 1, 3, 3, 5. And then 2, 4, 6. This is what we want, right? The transpose of this matrix. So to do it in using just Python list, we can use, we can obviously use for loops. I'll just use list comprehension. So we'll do it in one line. We'll try to do it in one line. Okay. So we are basically writing loops for, say, row in matrix. For row in matrix, what do we do? Okay, now can we actually do it in a single line? I'm not sure. Okay, let's just do one by one, then we'll shorten it up. Why not? For row in matrix, and then we have a, say, resultant. Let's call it transpose. And then for each row, what we want to do is we want to form a temporary temporary element with all of these items, and then we want to import it into trans, right? Or let's just do it the other way. Let's just do it using range. I think that will be the easiest. Let's just do trans equals to, so we know what the shape of trans will be, right? 0, 0, 0, and then something, say, it will be like 0 into length of matrix 1, 0, for I in range len mat 1, or len mat, I think this is it. Is this it? Okay, no, sorry. So this should be this. So what we are doing here is basically we are creating a new matrix, all filled with zeros initially, and what we are doing is we are basically filling, like we are just swapping the dimensions. So the inner dimension, which is this, will be of the number of columns, sorry, number of rows. Length of mat will give you the number of rows, which is 3 in this case. And the outer dimension, this is our outer dimension, that is like the number of columns in the original matrix. So if we look at trans, we will get trans. You can see it is already in the right shape, right? So now we want to just fill it up, right? So we will do something like for I in range len matrix, and then for j in range len matrix 0, right? So what do we want to do here? We want to do trans j I equals to matrix I j. That is basically what transpose is, right? We are just swapping the dimensions. If we run it and if we see what trans is now, you can see that it is the transpose of yeah. So now can we do better? I think so, but yeah, so the one line version of this would be trans. We are just doing the same thing but in a list comprehension format. So list comprehension, we can just take these for loops and put them in the same line, basically something like this, and then the inner loop. And then inside there will be this. So this is our one line transpose. Let's see if it works. Let's run it and let's see. Trans. Yeah, no, trans does not work. Okay, let me see. Okay, sorry, we have to do j comma I here, because yeah, we just swapped. So it's basically, it would have been the same if we did something like this. That's what we are doing. So we have to just change the dimensions. I think we have changed the dimensions. Yes, something like this. So yeah, this is let's trial and error. So yeah, this is how we get a transpose in one line. So now you can see we have gotten the right answer. So what is going on here is the same as what we did in a for loop in a normal fashion, but we are doing it in one line using list comprehension. So we are just iterating over these items in the matrix in like opposite order in j and I, and you have to just take care of what I is and what j is. That you have to just be mindful of. So here ij will represent the position of the transpose matrix. So even though I represents the number of rows in the trans matrix, so it will go up to the range of the number of columns in the matrix, original matrix, and the number of columns in the transpose matrix will go up to the number of rows in the original matrix. Okay, it might seem a bit confusing, but it is not. And then if you have, say, numpy, so this was if you have a normal list format as np. If you have a numpy array, suppose say let's call it nmat, just to np.array mat. Okay, so let's see how it looks like. Nmat. So nmat, it looks like this in a numpy array format. So to find the transpose, what you do is just do nmat.t, I guess. Yes. So if you have something, a metric stored in a numpy array format, then just dot t. If you do dot t, then it will give you the transpose. I think you can also do numpy.transpose. Yes, nmat. I think this will give you the same answer. I think you can also do it with a normal, yes. So np.transpose, you can also use it with a normal regular list, like this matrix. This is a regular list. So I just did np.transpose matrix mat. It is giving us the answer in the correct format. You can also obviously do it with a numpy array, numpy matrix. And if you have it stored in a numpy matrix, you can just do dot t. That will give you the transpose. But yeah, I don't think so. For matrices of like more than 2 dimensions, I don't think it will work. Let's see. I don't think it will work with, say, if you have a matrix of like 3 dimensions, will it work? Transpose. So this will work. Something will happen, not the thing that you want, but let's see what it is. It is like something. But yeah, so what I mean to say is, so suppose this is our matrix. So if we do just nmat.t, we'll get, yeah, we are getting the transpose nmat. So what dimension is it swapping? So yeah, it is basically transpose is swapping the last 2 dimensions. It is keeping the first dimension the same, or no, the first 2 dimensions, sorry. So yeah, you can just experiment with numpy like this. Just try to find out what are the what transpose is it working on. So here you can see that it has swapped the first 2 dimensions, 1 and 7, right. Or the first and the third, sorry. Okay. Yes, first and last dimension. Okay, that's it. Okay, anyway, so let's just stick to 2 dimensions. That's easy. Okay, so any question about this, especially about this one liner? So I think it's this nmat.numpy matrix.feeds is like simple, straightforward, nothing to do. Any questions about this? I hope this is understandable. This is basically the same thing as this. Basically something like this. J equals to J, something like this. These two are basically the same code, just in one line format. Any question? I think it's past time, so let's not start another new question. But yeah, so I'll be sticking around for a couple more minutes. If someone has any questions, stop the recording.